Hi everyone, my name is Taylor England and I will be teaching you about the Krebs cycle in today's lesson. The Krebs cycle may seem difficult for many people to comprehend, but don't stress. We will be going over the Krebs cycle in 8 easy steps today. So glycolysis takes place in the cytosol where it forms pyruvate. Pyruvate is then transformed into acetyl-CoA, which takes place within the mitochondria. So yes, essentially what I'm saying is that the Krebs cycle takes place in the mitochondria. There are 8 key molecules in the Krebs cycle: citrate, isocitrate, alpha-ketoglutarate, succinyl-CoA, succinate, fumarate, malate, and oxaloacetate. A mnemonic that can help memorize the molecules in the Krebs cycle is, "Can I keep selling soup for money, officer?" And remember, succinate is always late, reminding that it comes after succinyl-CoA. So step 1, acetyl-CoA forms with a 4-carbon molecule, oxaloacetate, which in turn forms a 6-carbon molecule, citrate. This can be seen in fruits such as oranges and lemons. Step 2. Citrate is converted into its isomer, isocitrate. This is technically a 2-step process. This is because it first results in the removal of a water molecule, then the addition of another water molecule. Step 3. Isocitrate is then oxidized and releases another carbon dioxide molecule, leaving behind alpha-ketoglutarate, which is a 5-carbon molecule. This is when NAD+ is reduced to NADH. Isocitrate dehydrogenase is the enzyme responsible for accelerating this specific step and overall controlling the rate of the Krebs cycle. Step 4. This step involves the oxidation of alpha-ketoglutarate, which reduces NAD+ to another NADH and releasing another carbon dioxide molecule. What is left is a 4-carbon molecule that picks up coenzyme A, which forms succinyl-CoA. Alpha-ketoglutarate dehydrogenase controls the speed of this step. Step 5. A phosphate group exchanges for the CoA group of succinyl-CoA, which creates ATP or GTP. Succinate is then the molecule that is created during this step. Step 6. This step is when succinate is oxidized further, forming a 4-carbon molecule, fumarate. FADH2 is produced during this step when 2 hydrogen atoms are transported by FAD. This is why the Krebs cycle taking place in the mitochondria becomes important. This step permits the electrons that are a part of FADH2 to be directly transported into the electronic transport chain. Step 7. Water is supplied to fumarate during this step, which is then converted into malate. Step 8. This is the last step of the Krebs cycle. Malate is oxidized during this step, reducing one final NAD+ to NADH and eventually regenerating oxaloacetate. The Krebs cycle is important for cellular respiration. Cellular respiration occurs when glucose, fatty acids, and special amino acids are oxidized, and in turn, their energy is transformed into ATP. ATP is commonly referred to as energy currency because it supplies energy for muscle contractions. Now, let's look back on the Krebs cycle as a whole. One single turn of the Krebs cycle results in 6 products. 2 carbon dioxides are released, 3 molecules of NADH are produced, 1 molecule of FADH2 is produced, and 1 final molecule of ATP or GTP is produced. However, glucose produces 2 acetyl-CoA molecules, therefore numbers must be multiplied by 2. This then results in 4 carbon dioxide molecules, 6 NADH molecules, 2 FADH2 molecules, and 2 ATP. Thank you, and I hope you enjoyed my presentation.